Good morning, dear children. So, last class we were learning about metalloids. Metalloids are elements having metallic as well as non-metallic properties, and we are learning about some uses of some common metalloids, and we learned about the uses of silicon in modern electronic and computing, and several uses of silicon. Silicon is used in watches and clocks also. Silicon is used for making bricks and concrete also in the form of silica. Then silicon is used for toughening of the steel and all. Then germanium is also used in the manufacture of wide-angle camera lenses. Then it is also used in semiconductor industries. And then for inner coating of the fluorescent tube also germanium is used. Now today we'll be learning about the uses of arsenic, the another important metalloid. Small amount of arsenic is used in making alloys. So a small amount of arsenic is used in making alloys. For example, certain parts of lead storage batteries used in cars and trucks are alloys of lead and arsenic. So the batteries that is used in cars, that is used in trucks, are lead storage batteries. Their name is lead storage batteries, and these lead storage batteries are alloys of lead and arsenic. So small amount of arsenic is used in lead storage batteries also. This element is widely used in compounds. So for making compounds, arsenic is used. Arsenic was also used to make lead shot in the past. However, the amount of arsenic used in such applications is likely to decrease. So previously, for lead shot also arsenic was used, but now the use of arsenic is decreasing. That means the application of arsenic is likely to decrease, means they may not use arsenic for lead shot. Then trace amount of arsenic is also used in the electronics industry. So in electronic industry also trace amount of arsenic is used. When added to germanium and silicon, it is used to make transistors. So you are very much familiar with the word transistor. Radio is also called transistor. That means the work of transistor is to catch the signal sent from the satellite and to convert the frequency and convert the signal into the audible, the understandable language, that is transistor. So for making transistor also germanium, silicon and arsenic are used. A compound of arsenic called gallium arsenide is used to make light emitting diodes, LEDs. So these LEDs, I think you are very much familiar with. LED, now TV are also LEDs, then mobile phone LEDs, even our bulb is also LED bulb. So LED, what is the full form? Light emitting diodes. And for making this light emitting diodes, what is used? Gallium arsenide is used, a compound of arsenic and gallium. A compound made up of arsenic and gallium, that is gallium arsenide, is used to make LEDs. These LEDs are widely used in handheld calculators, clocks, watches and a number of other electronic devices. Then another one is tungsten. So this tungsten is another metalloid which is used from olden days. Even Thomas Alva Edison also used this tungsten in the filament of a bulb. So let's see some uses of tungsten. In traditional incandescent light bulbs, tungsten was extremely used in the filament. So then there was no system, there was no bulb when Thomas Alva Edison made the bulb. So then this filament lamp was only used, okay, as the source of converting chemical energy into light energy. Means it used to give us the light, that means electrical, sorry, not chemical, electrical energy into light energy. The device that can convert electrical energy to light energy was this filament bulb only. So traditional incandescent light bulbs, tungsten was extremely used in the filaments. The filaments, so you can see the arrow out there. This arrow shows there is a curly wire. This wire is made up of tungsten. So if this tungsten breaks, then the bulb does not glow. So previously we used to check a lot whether this when the bulb does not glow, we used to take out the bulb and we used to see whether this curly wire is broken or not. So if it is intact, then there must be some problem. Otherwise, if this is broken, then we have to replace the bulb. So that means tungsten is used in filament bulb also. Among all the metals, tungsten has the highest melting point. That means why it was used by Thomas Alva Edison for making filament of the bulb, because its melting point is highest. It melts at a very, very, very high temperature, which is not possible in the ordinary condition. That's why it was used. It is alloyed with other metals to provide strength to other metals. Also, tungsten and its alloys are widely used in many high temperature applications. That means since it does not melt very easily, its melting point is very high, it can be used with any of the things where we need high temperature, such as arc welding electrodes and heating elements in high temperature furnaces are made up of tungsten. Tungsten carbide, an immensely hard material. So tungsten carbide is immensely hard material which is important for metal working, mining and petroleum industries. Tungsten is also used to make excellent cutting and drilling tools. So since tungsten doesn't melt easily, its melting point is very high, so it can be used for making cutting and drilling tools, including the new painless dental drill. So painless dental drill used in dental surgery, used by dentists, is also made up of tungsten, which spins at ultra high speeds. Tungsten in combination with calcium and magnesium are widely used in fluorescent lighting. Even when it is combined with calcium and magnesium, it is used in fluorescent lighting. Then last one is antimony. Antimony is used in making alloys with a number of different metals. Lead antimony alloys are used for solder. Solder, I think you have heard of. Solder is used by mechanics for joining the broken parts in electronics. Ammunition means arms ammunition. Fishing tackle, covering for electrical cables, alloys that melt at low temperatures, and batteries. The alloy of antimony is used. Antimony is also used in lead storage batteries, which account for about 1/5 of all the antimony used each year. So antimony, a huge amount of antimony is used in lead storage batteries. Now just before this also I said one of the metalloid is used in lead storage batteries, and what is that? Which is another metalloid that is used in lead storage battery, that is arsenic. So small amount of arsenic, small amount of antimony is used in lead storage batteries. And trace amount of antimony is also used in making transistors. That means you can just say antimony and arsenic have a lot of similarities. Arsenic is also used in transistor and antimony is also used in transistors. Arsenic is used in lead storage batteries and antimony is also used in lead storage batteries. Then alloys that covering for electrical cables. Okay, so found in electrical devices such as computer, games, pocket calculators and portable stereos. Trace amount of antimony is used. Antimony is also used in manufacturing of glass, ceramics and production of plastics. Use of antimony in glass and ceramics ensure the product to be clear and colorless. So antimony is generally used in glass and ceramics to make it very much clear and colorless. So with this we have done with the uses of metals, non-metals, noble gases and metalloids. So next class we'll be learning corrosion of iron. This much for today. Thank you.